So today we are continuing with derivatives. So remember yesterday we found the slope of the tangent line. Okay, and today we are going to be finding derivatives of the functions at a point. Okay, and when we were finding the slope of the tangent line, we were using limits. We're going to be using limits today as well. So the derivative of a function f at a number a denoted by, and this is our notation for the derivative, is f of a is equal to the limit as h goes to 0, f of a plus h minus f of a divided by h. Okay, this is the same formula as what we used to find the slope of a tangent line. They are one and the same. Okay, so when you are finding a derivative, you are finding the slope of the tangent line. When you are finding the slope of the tangent line, you are finding a derivative. Okay, so they're going to give you some function f, okay, and it's going to be at some value a. Okay, that will be some number. Yesterday we were given points. Today we're just going to be given a value. And this means we could also use the limit as x goes to a. We are going to be using that today, but we're also going to be using this first one. And that's just because with some of these, you might get stuck if you used this equation. You might have to do a little bit more work. Okay, so this is a tried and true when we are given a value for a. Okay, and then we'll talk about when to use this one versus when to use this first one here. Okay, so a lot of the things we're doing on the first page are going to feel familiar because it is what we did yesterday. There's a few small changes. So when you're finding the derivative of the function, f of x equals 8x squared plus 2x minus 4 at 2, what that means is your a value is 2. So our notation, we would say the derivative at 2 is equal to the limit as h goes to 0. And remember, we do have to keep writing that limit out. Okay, so the limit as h goes to 0, f of 2 plus h minus f of 2 over h. So anywhere there's an a, I'm going to plug that in. So what we did yesterday is if we had to find f of 2 plus h, if we had to plug that in and there was a lot of algebraic work, we did that on the side so that when we plugged it in, it just looked a little bit cleaner. You are welcome to do that today as well. So we're going to do f of 2 plus h. So it's 8, 2 plus h squared plus 2 times 2 plus h minus 4. Okay, so I'm going to give you some time right now to simplify that down. All right, so let's see how we did. Okay, so when you FOIL this out, 2 times 2 is 4, 2 and 2, 4h plus h squared. Distribute to get 4 plus 2h minus 4. So we have 32 plus 32h plus 8h squared. The 4 minus 4, those are going to cancel. Okay, so then I have 8h squared plus 32h. Oh, sorry, plus 34h if I combine those together. So 32 and 2, okay, plus 32. All right, so that's what we're going to go back and we're going to plug that in. Okay, so this is still the limit as h goes to 0 of So I have 8h squared plus 34h plus 32 minus, and then it's minus f of 2. So yesterday we were given the point, so we had the output. Today we just have to find it. So to do f of 2, we're just going to plug that into our equation. So it's 2 squared plus 2 times 2 minus 4. So we have to follow the order of operations. So we have 2 squared is 4, 4 times 8, 32, plus 4 minus 4, so this is going to be 32. So that is what I'm going to substitute in here. Okay, so you do need to show this step. So you have to show what you're plugging in for f of 2, what you're plugging in here. Okay, so don't skip any of your steps. Sometimes that's the hardest part, is to make sure you're showing what you got to show. Okay, and then we're dividing by h. So when you divide by h, then you get the limit as h goes to 0 of 8h plus 34. So remember that you can't plug in 0 here. If you plugged in the 0 here, you would get the indeterminate, 0 over 0. But you can plug in 0 here now. So when you substitute that in, you just have to show what you're substituting. So 8 times 0 plus 34. So you have to show this step. Okay, and then the way that you write your final answer is the derivative at 2 is equal to 34. Okay, that's your final. So very similar to yesterday, except instead of saying that it's the slope, it's the derivative at 2. Hey, I kept writing the ds for direct substitution. You can write that if you want. You do not have to. Okay, you just need to show the direct substitution. All right, any questions for me on part A? So that's a algebraic function, right? We have that trinomial. Here we're going to have a rational function. So we did talk about this a little bit as well. So we're going to find the derivative at 1. So the limit as h goes to 0. Okay, see if you guys can do the first step. So it's f of something minus something over something. Okay, so whatever they give you here, that is your a value. So this becomes 1 plus h, okay, and then it's going to be minus f of 1 divided by h. Okay, so again, if you want to simplify on the side, you can. If you want to plug it in, that's fine too. In this case, you have to plug in 1 plus h in 2 places. So you're replacing this with x. So instead of x, we have 1 plus h over 1 plus h plus 1, because this is x plus 1. So 1 plus h plus 1. Okay, you can keep it as 1 plus h on the top, or you can write it as h plus 1. Okay, and then the bottom we're going to simplify to h plus 2. Okay, so this is what we're going to substitute back in. All right, so it's going to be the limit as h goes to 0 of h plus 1 over h plus 2 minus, okay, and then we're going to do the f of 1. So 1 over 1 plus 1 is 1/2. Okay, and honestly, that is something that you could do in your head, and you could just put minus 1/2 here. Okay, that's fine. 1 over 1 plus 1 is 1/2. Okay, and then it's divided by h. Now, we did one like this yesterday. If you have a fraction, do you guys remember what we have to do here? You're going to multiply by the least common denominator. Okay, so what is the least common denominator here? 2 times h plus 2. Yep. Okay, now when you multiply by that LCD, remember that you are distributing, okay? And I'm going to write out this step. I think it's helpful. Because you're going to see some fractions here. So when you're multiplying those out, you can cancel out and then you can multiply by what needs to be multiplied. Okay, so we're multiplying this by 2 times h plus 2. We're multiplying this by 2 times h plus 2, the negative 1/2. And then on the bottom, we're also multiplying. But we talked yesterday about how when you're multiplying, right, you really keep those as a product. Okay, you're not going to distribute those because usually you have some type of cancellation. All right, so then if I'm canceling out the h plus 2's, I can see I'm going to multiply 2 times h plus 1. So I have the limit as h goes to 0 of, so 2h plus 2. And notice how that's going to get rid of that complex fraction. Here I can cancel out the 2's, just don't forget to distribute the negative. So negative times h, and then negative times 2. Okay, and then this on the bottom is 2h times h plus 2. Okay, go ahead and write out the next step. Really, you should be able to write out the next couple steps. And then make sure you are not skipping anything. Okay, so the 2 and the negative 2 cancel. 2h minus h is going to be h. So you have h over 2h times h plus 2. Your next step, you have to simplify the h's. So that becomes 1 over 2 times h plus 2. And you can leave it just like that. So I couldn't plug in 0 here. If I did that, I would get 0 over 0. Okay, if I plug in 0 in this step, am I going to get 0 over 0? No. So whenever you can plug that in, you're going to do that. And again, you just have to show this step. You have to show where you're plugging it in. Okay, you have to show that you substituted 0. And then from there, you get 1/4. So we say the derivative at 1 is 1/4. All right, so those are pretty much the exact same as yesterday. Except instead of you given a point, you're given your first value, which we call A. And then a little bit of a notation difference in how you write your answer. All right, now we're going to utilize that second formula. So when you go to the back and you read through example 2, I want you to notice something different in the directions. So once you have that copied down, go ahead and go to the next page. And then I'll know you're finished copying that down. Okay, so on the back it says find f of a, where a is in the domain of f. So before, we were finding these values at a given number. A was a number. Here, we're finding the derivative at a. What this means is your solution is going to have the variable a in it. So your solution has A in it. I'm putting that in quotes so you know that we mean the variable. And you don't go back and read it and say, we don't have a what. Okay, so you're going to have the value of A in your final answer. Okay, and then it says A is in the domain of F. All that means is you will get a real solution. Okay, it's not undefined. Okay, so if you are finding the derivative at A, we are going to use the limit as x approaches A. Okay, so the derivative of f of A is equal to the limit as x goes to A of f of x minus f of A over x minus A. All right, so now we're going to plug in some things. So f of x is just the equation. F of x is just the square root of 7x, so that's what we plug in for f of x. F of A is just this equation, but instead of x, we're going to replace it with what? A, right? Okay, so it's just going to be the square root of 7a. Okay, on the bottom, there's nothing to substitute. You're going to leave it as x minus a. And then just like we were doing when we were solving limits with algebra, we're going to solve this algebraically. So anytime we have a square root, what have we been doing to solve with algebra? What have we had to do? Yeah, rationalize the numerator. Okay, so to rationalize the numerator, we're going to multiply by the conjugate. Okay, so write down what you think the conjugate is. And I will ask one lucky winner to tell me what they think it is. All right, Lucas, come on down. What is the conjugate? You got it. You're the next contestant on. The derivative is right. Okay, so you're going to multiply by the root 7x plus root 7a. Okay, so we're going to be foiling in the numerator. And then in the denominator, remember, we're just going to keep that as a factor. So if you want to write that down first, that's fine. We still need to write the limit as x goes to a. So when we multiply those together, it's x minus a times root 7x plus root 7a. All right, and then I'll give you a minute to FOIL on the top there. All right, and then Kenley, let me know what you got for the numerator here. Great, 7x minus 7a. So root 7x times root 7x is 7x. Inside and outside are going to cancel. Root 7a and root 7a is 7a. Because they're opposites, you'll have that minus. All right, great. So what should I do now? What can I do? Yeah, great. Factor out that GCF. So we're going to factor out the 7. So if we factor out the 7, we get x minus a times 7 in the numerator. Okay, and if you were unsure that that's what we were going to do, just remember that our goal is to be able to cancel something out. So if we want to cancel something out with x minus a and we have those, think about, hey, can I take something out of here that's going to simplify that down. Okay, and then once you have that common factor, you do have to write this limit out one more time. The limit as x goes to a of 7 over, and then you don't need the parentheses anymore now that we aren't multiplying by anything. All right, and then once you get there, so we couldn't plug in a here. If we were to plug in a in this step, a minus a would be 0, and we'd end up with 0 over 0. But now we can plug in a and we won't get a 0. So just like we were doing before, we're going to be doing that direct substitution. It's just instead of plugging in a number, we are going to plug in a. Okay, so we are going to plug in a for x. Okay, so you're plugging in that variable for x. Okay, so you're doing that direct substitution. Okay, which is x is now going to be replaced with your a. So I have 7 over. So in the direct substitution, x becomes a. So it's the square root of 7a plus the square root of 7a. Now we're just going to simplify. Do you guys know what that's going to be? Yep, 2 root 7a. Great. Okay, so the derivative at a is 7 over 2 root 7a. So that probably feels a little bit different because we're used to getting a number. Okay, and now we will have an expression with a in it. All right, and then for part B, we're going to do the same thing. So when you're starting this off, if you want to write this out as your first step, you can. Okay, you can also just substitute those right away. That's fine too. Okay, so if you go right to what that's going to be, that is fine. So we have f of a is equal to, so if we're doing the f of x minus the f of a, okay, over x minus a. Is it okay if I don't write that first step? Are we doing okay? Because all we're doing here is your f of x. Okay, so f of x is just going to be x over x plus 1. And then it's a minus, and then when you plug in a, it's a over a plus 1. All right, and then we have a fraction. So we've already done this once today. I want you guys to write what you're going to multiply by. And then again, we will call in a lucky winner to tell us what it is. All right, Aloria, what'd you get for your LCD?
X plus 1 times a.
Nice. X plus 1 times a plus 1 is what we're going to multiply by. Okay, so when you multiply by your LCD, you're going to multiply both of those in the numerator by the x plus 1 and the a plus 1. Okay, So the limit as x goes to a of x over x plus 1, okay, that gets multiplied by the x plus 1 times the a plus 1. And then it's minus a over a plus 1. Okay, the reason why I like writing this out is I feel like people make less small mistakes this way when they can see what's canceling with each one. Okay, you can't just cancel all of these out for both of them. Okay, you have to do the distribution process. Okay, and then in the denominator, we know that we're going to be multiplying the x minus a, x plus 1, a plus 1, okay, and now we can cancel those out. Okay. And if you want, you can do this step next. I'm going to write it out just step by step, but you could also skip this step and go to the next one. So if these cancel, I want you to understand you're left with x times a plus 1, and then it's a minus a. Those cancel. You're going to be multiplying by x plus 1. Okay, if you write out this step though, and you want to skip right to the next one, that's fine. Where you simplify. So where you do the distribution. So x times a, you can write it as xa or ax. X times 1 is going to be x. And then here, negative a times x is negative ax. Negative a times 1 is negative a. When I'm multiplying variables, I generally put them in alphabetical order. And that way, if you have two with the same variables being multiplied, you'll see that they cancel. Sometimes if you write xa and ax, it might take you a second to realize, hey, those are the same thing, right? So ax minus ax, you are going to get some things that simplify here. Okay, we're still leaving the denominator as factors. And then we can see these are going to cancel. So we have 1 over x plus 1, a plus 1. So here, if I were to plug in a, I'd get 0 over 0. So I can't do that yet. You can plug in a in the last one. Do you guys want to give that a try and see if you can simplify it? So you're plugging in the a for x. Okay, so then you'd have a plus 1 times a plus 1. How do we write that in simplest form? A plus 1 squared. Okay, so I'll just write the derivative like that. Yay! All right, so for today, your homework is on page 863. Okay, this is due tomorrow in Google Classroom, numbers 15 through 22. Now, make sure that you are writing your limit for each step. Okay, most of you are doing that. Did that on your homework from last night, but a few people are missing them in all their steps, and that's not something I want you to miss on your test, okay? So make sure you're practicing, and then you can use your notes to help you if you're unsure.